Hey everyone, got my buddy's Aquarium skimmer pump here. Doesn't fire up, got no readout on the LCD here for the control. And as well, the little LED light on the plug here kind of flickers when you plug anything into it. As well, we've got some pretty nice corrosion here on these contacts, which to be honest, I'm not really surprised. There's an O-ring on this side, but this is a plastic threaded connector. I doubt this is going to do much for water ingress, especially considering he's got a salt water tank. I've sprayed this a bit with contact cleaner as well as some penetrant spray. Gonna try and clean it a little bit more, then maybe dose it up with some grease afterwards if we get it fixed. Maybe some Teflon tape around here, but don't know how long that's going to last, to be honest. When we plug the power adapter in, we get a green light, so keep an eye on that green light right there. Now the pump itself's not plugged in. All I'm doing is going to be plugging in this controller. Light's gone out and kind of flickers back to life every now and again, every few seconds. And now that I've plugged it out, it's back to normal. So I'm thinking something's shorted out inside here. Problem is, I think this thing might either be sonically welded or super glued together. Taking these out doesn't really do anything in terms of giving you accessibility to it. There's a little ring there. Doesn't really come apart though. So what I'm thinking, I'm going to take the Dremel to this, go around here, sort of break it open. Actually, first, I'm going to try and peel back a little of this here. See if there's any hidden screws underneath here. It doesn't really feel like it, but just to be sure. And I'm hoping it's just some kind of weird corrosion, some kind of easily replaceable part. And if that doesn't work, we're going to see to just basically rig this thing to have the power cord just plug straight in here and run at full speed, hopefully. Now, when my buddy brought this over, there was a break in the wire right here. I didn't bother filming that part because I figured easy fix. You guys not going to be interested in that. And I was just going to enclose this entire part here with silicone just to keep it watertight. But you know what? Let's make sure this pump actually runs. Gonna hook this straight into the bench power supply. See if we get any kind of life out of it. To me from the future, just a quick clarification on what I'm trying to do at this part in the video. So right now I'm running under the assumption that this hole by itself here is a common ground, and each of these top two are energizing two different sets of field coils. So something like this. So here's a really crude drawing of what I thought was happening. This is the rotor here. I thought there was a common ground here, and then the other two wires I thought were going to two different field coils. So depending on how these two were energized, you would kind of be able to adjust the speed that way. But those of you that recognize this type of motor probably know what I'm doing wrong. So I won't give too much away. Back to the video. Got some copper. Just going to put it inside here, then clip the bench power supply to each terminal. Going to be shooting 24 volts, 1.5 amps into it from the bench power supply. Alright, everything's connected. Going to turn on the bench power supply now. Got a tiny bit of life out of that. Let's try this other connector up here. Right. Before we tear this thing down anymore, let's see if we can get this working. See if we can get this label off. So far, no screws. Rather not pull it back all the way if I don't need to, but yeah, there's no screws on this side. Gonna try lifting this as well, just for good measure. And no screws. Welcome to the garage. Let's see if we can cut this thing open without killing ourselves. Success. And there's your problem, lady. Looks like this wire right here is hanging on for dear life. And I'm not 100% sure if there's components that should be here. Got the light right here. And yeah, still goes off when we plug this in. So I'm assuming there's damaged components on this. So unfortunately, we weren't lucky enough to get away with just cleaning this. Right, so it turns out I'm not very smart. This is a brushless motor. As such, this is a brushless motor controller. My hopes of just feeding some power into these wires and getting it to run, no bueno. From what I understand, the coils in here, they're not static, so to speak. They have changing voltage going through them, which is where this thing comes in. I am going to try to feed 2 volts into this thing with the bench power supply and try to see what gets hot. And mind you, I'm still not sure if something exploded from right there. So here's what we're going to do. I am going to hook this up to the bench power supply at 2 volts and have it current limited to 2 amps, and gonna flip that on, put some 99% isopropyl on this, and what should theoretically happen is the bad components should start overheating and dry up the isopropyl at a faster rate. Okay, bench power supply is on and it is drawing 2 amps right now. Looks like these chips are okay. Let's try the back. Actually, right off the bat, I can feel this one getting warm. Let's just prove it. Yep. See how fast that one's drying up? So this MOSFET right here, that's the culprit. Let's see if we can track down some spares. So here's the deal. This MOSFET, for me to order this from AliExpress, I'll have to order 30 pieces for 30 bucks essentially, which, considering the state of the board as well, I am not keen on doing that. So backup plan time. And right here, this is the backup plan. Got a brushless speed controller, courtesy Amazon here. Already comes with the variable resistor and the power switch. Just gotta get the DC inputs in here, and hopefully that ABC lines up with this WVU here. We'll see. First order of business, desolder these. Then we're gonna cut them back a bit just to get rid of these corroded ends right here. These thankfully are screw-in terminals, don't need to solder anything. We know that the red wire from the power supply is positive. And as for this one, for now, I'm just gonna go with the original order that we had. Time to plug this in, test it out. We've got a green light shining on that. And let's see what happens when we plug this in. Hopefully no fireworks. Okay, that light's still on. That's more than we had before. Let's connect up the motor, connect the power again. Looks like we're actually working. Now, only thing is, I believe this thing is spinning in the wrong direction. I believe it's supposed to spin this way to kind of shoot water up that way. Currently this thing's spinning in that direction. Gonna try switching this red and blue wire, see if that helps. And let's see if this made any difference. Yep, we're now going in the proper direction. Okay, so there we go. One fixed skimmer and one trash controller. Gonna pass this back to my buddy. Gonna have him silicone this entire area just to keep it watertight. He's got some special silicone used to repair aquariums, he said. And as for this, I'll see if I have some kind of casing this thing can be put into. I'm a little loath about completely enclosing this thing, just because it looks like this thing might bleed off a lot of heat. There's quite a few heat sinks on this. And I'll clean up these wires. As you can see, some of them a little bit nicked. But yeah, it works. Thanks for watching.